Hello, and welcome to the chapter on network evolution, chapter 7. In this chapter, we are going to cover the Internet of Things, the new and the latest upcoming topics in IT, the field. We'll talk about cloud computing and virtualizations and how they are being used together to enhance access to devices or resources offsite. And then we'll talk about network programming, how you can actually have a virtual network where all the processes of interconnecting devices happens outside your network, outside your physical network. So you don't really need any CPU or a lot of power to process or can interconnect your devices together. All right, so let's look at the IoT first. Cisco estimates that about 50 billion things will be connected by 2020. That's a lot of stuff uh, from the heating, air conditioning, ventilations, your telephone, your power. All of that are going to converge together. You know, video surveillances, refrigerators, not your cars. All of them are going to be interconnected with each other. Not only that is going to be really a good thing, but also security is going to be a major issue, of course. So we are going to need um, experts in maintaining, developing them, designing them, interconnecting them, making sure they are well secured. So there are going to be great job opportunities in the near future within the next 5 to 10 years. And also, they say that 99% of all the things are not connected yet. And I think slowly you will see that in the near future. So that's something to really be thinking about. Your next career may not be sitting in a local area network and trying to troubleshoot computers or things like that, but it's probably your first desktop. Your first desk help may be for the Internet of Things on how to connect and maintain and troubleshoot and all those good stuff. And of course, again, like I said earlier, security is going to be a major issue when it comes to that. But we'll take it as it comes. All right. The big challenge, there are several elements within the IoT. So again, as I've been saying, securely to integrate all of these millions and millions of devices is going to be a challenge. So there are about 6 pillars that Cisco takes a look at. Network connectivity. So that's going to, how are we going to connect all of those Internet of Things together? The devices that are going to connect to each other, all the different types of devices. I don't even have to mention them. There is also fog computing that's going to allow when you have pretty close networks, uh, you can have devices to run applications locally and make decisions instead of too far. The difference between fog computing and cloud computing is all the computing is done on very far away to a third party, no matter where they are. But they could be very, very far from your network, but all the decisions, all the computing happens, the processing happens off-site. But if you have several networks within, let's say, a city limit, so each network, they can process some of their information and then being able to get services from another network using the fog computing. So they'll be able to do that. I don't know. I mean, Cisco likes to call it fog computing, but it's still because some of the process actually occurs locally. You can still call it cloud computing as far as I'm concerned. The next thing is security. It has to be scalable cybersecurity solutions, and how we're going to do that with the IoTs. The data analytics, creating APIs, application programming interfaces. Those APIs allows other programmers to write programs to communicate and allow all of these different devices communicate with each other. So how do we create these APIs to allow all of these different, there has, the APIs are the ones that allows you to, it's a set of rules that allow other programmers to use these set of rules to enable them to enable the devices to talk to each other. For example, Microsoft will come up with a whole for the local machine. Will come up with several APIs and gives them out to all the different programs. So any programmer that wants to design an applications to run on Microsoft operating system will use the APIs to allow them. So when they use those APIs, they'll be able to design a program that were run on a Microsoft operating system. So those APIs we're talking about is to allow different types of devices to communicate with each other. Also, a next pillar is the management and automation. Having somebody that we can manage and automate devices remotely, right? And of course, application and enablement and provide infrastructures for the application and hosting and all of, this is probably a big thing that everybody really uses the cloud computing for, the Internet of Things, being able to communicate with each other with those little devices, applications that you can use remotely. All right. Let's get now to, oh, by the way, sorry about that. I wanted you to write those 6 pillars and their definitions, the IoT 6 pillars. So that's the first thing that you want to write down. All right, let's take a look at what cloud and virtualization is. Cloud computing. Cloud computing, it involves a large number of computers connected through a network that can be physically located anywhere in the world. So instead of having a server locally, you'll have the server somewhere else. A third party takes care of it, and you can access that server, but all the computing happens, the processes of what you want happens there. You just send the data, their processes, they save it for you, they split it up for you, they try to figure out whatever. You just send the data and they take care of it instead of having to do anything locally. Not only that, you'll save um, on the administrator, having an administrator to locally update the information or whatever that you need an administrator to do to the data that you are sending instead of doing it locally. Now you just send it um, remotely somewhere else. By the way, the difference between cloud computing and, you may get that confused, and data centers is just stores data remotely, right? There is no computing happens. You just have a hard drive somewhere else that just stores data and you have access to it. But when we're talking about computing, is a processing actually happens to that data that you are saving. They can calculate things for you, figure out, program it, whatever you need to do, secure it. Well, for our case, for example, when I write down, when we send, oh, for example, when it comes to attendance, when I take attendance, I just send out the attendance remotely to Salesforce. Salesforce is a big cloud computing company, and what they do, they can process the names, figure out where to place it, save it. If they need to upgrade the application remotely, they'll do it securely. Whatever they need to do, and you'll always have connections 24/7. So all the connections, all the security happens remotely. Now, there are actually 4 cloud computing services that are being offered. Software as a service, right? So they can actually have applications over the web. So you can access applications remotely, right? That would be that, data centers don't do that. So you can have an application such as Microsoft Word or any applications, instead of storing it on a local server, you can access it remotely, right? Um, Platform as an operating system, tools and services, even operating systems they can send you down. Uh, so what type of tools that they can have to send you and services, other services other than software that they can have. So for example, using the attendance, anything that you want, you can have like somebody from Salesforce comes in and says, okay, what do you want? What do you want that you are doing locally right now? And almost anything that you could do locally, you can remove it and put it in the cloud. Like I said, having somebody out there to do it for you and process it. Infrastructure, they can actually have hardware and software and will be able to turn on and turn off um, servers that are locally. So you can, from home, you can control a lot of the hardware that is locally. That's the IaaS, the infrastructure as a service. And now they have even IT as a service, okay? Which allows you to even, extend the capability of the ITs without having to really pay for any new investments or training new personnel or licensing new software. So you can have desk help desk, you name it. All of that can be all done remotely because really you reducing almost there is locally you probably will just have local machines and all you need to when you need to access anything you can access them pretty much in the cloud. Organizations have not moved everything into the cloud, but slowly as we trust the security of the cloud computing, I think more and more app applications and even tools will be moved locally. So again, that's probably another thing that you think about. You'll probably either be working for a cloud computing company such as Amazon or Salesforce or even Microsoft instead of working locally. And how do you connect all of these different devices and secure them? You know, things are really kind of moving rapidly in that direction. All right, so your train of thinking has to be in there. All right, so cloud computing, I want you to write down those four different types of services that cloud computing's offers us. All right, the primary models for cloud computing are the public ones that, it's being offered for the general population to use. The private ones, the one that are only for a specific organization. There's community clouds also, really kind of private. This is for specific organizations that they have their own security and authentication methods, specifically made for that organization. And you have the hybrid, which is really a mix of public and private. So actually there's three: public, private and community is pretty much the same, and hybrid. All right, virtualization. Just give me one second. Another technology that allows you to save not only money and time is virtualizations. Instead of running several operating systems or several servers on on different machines, you can have one rugged, tough server that you can run all your servers, all your applications on. So you can have one big, huge machine that can run your file server, application server, radius servers, web server, all of them on one machine, and you can access everything on that one machine. And they act completely as separate servers, right? And if you could, you can control each one separately. So not only that you are saving on on the machine itself, even if one machine or one of those virtual machines fails, it will not affect all the others. All right. And how do we do that? So usually what you do is you have a hypervisor. A hypervisor is a software that runs on top of the operating system and that allows you to have these different servers, and they will allow you to communicate. The hypervisor allowed all of these different virtual machines communicate with the physical hardware of the device, right? So um, the advantages of virtualization is, of course, less equipment, less energy, less space, and so on. So please write down what the definitions of virtualization and what the hypervisor do. Okay. when it comes to virtualization. There are really there are two different types of infrastructures when it comes to virtualization. There's type 1 and type 2. Type 1 is where the hypervisor connects directly to the hardware. So all your different types of operating systems connects directly to the hardware of the device. This way you can actually turn off and turn on the operating system. But typically what's done is we do type 2. Is the hyper there's you have the original host, the computer with its own operating system, and then the hypervisor communicates with the operating system itself, and then all these applications, all these virtuals have the communicate with the hypervisor, and the hypervisor passes the data to the host operating system, and then you can go directly to the hardware. This is where you can have Hyper-V from Microsoft. Um, we can have VirtualBox to create that, Oracle VirtualBox, VMware. There are many different types of virtualization applications, hypervisors that allows you to do all of this, right? Okay, so again, type 1 allows you to manage using a management console to control and automatically move, consolidate, power, and turn off servers. That's probably the one reason where you can have doing virtualization. So most of your applications, by the way, remotely are done using virtualizations. You can create, by the way, your own cloud. So you can have your own facility somewhere where you can run a virtual server and put a hypervisor in there and put all your servers up there, and you can remotely access all of these servers from anywhere. So it does not have to be done locally. And the reason you probably want to do that for for security purposes. So you can always, I don't know. But the problem is then you're going to have to manage all this cloud by yourself. I don't know why you want to do, the whole idea behind cloud computing is to not to spend so much money, of course. Anyway, moving on. Network programming. Network programming is where we can have a software-defined network, SDN, which means we can have a software that allows the data to be processed where you can find the destination of who you're trying to get to done in a software, not locally. So right now, when you pass data, there's a control plane and a data plane. The data plane is the one that forwards you data using a plane processor like a DSP without the CPU. But if you have a control plane, the control plane is when, for example, right now, when the data comes into a router, the router will use the CPU to calculate and figure out the best route to the destination and build the routing table and all that goody stuff. When you have an SDN, you remove the control plane, and that's done through a software. So the data plane is passed from you to a software instead of a router, let's say, or a switch, where they actually calculate and figure out the best route to the destination, right? So you really have, you don't need, and by the way, so what that means is you have a whole bunch of devices connected to this cloud, which is really a software, an SDN. So you can have a local area network, quote unquote, but the interconnecting device is a cloud, a software, an SDN, right? That's what it means. So that's a kind of nice, I guess. But then you have to know how to program this SDN to allow all of these devices to communicate with each other. That's what it comes down to. So now we are really working on how to configure the switch or the router, but in the future, you're going to be configuring a software, a cloud software to allow all of these different, in the cloud, to allow these different devices to communicate with each other. Not only that, the advantages of that, of course, you really are removing the central point of failure. The router or the switch, for example, may fail, and then you may not have any connect communications with your other devices. But now, if that's in the cloud where you can have, you know, almost infinite redundancy, so you probably will guarantee to always be connected no matter where you are. You could be at home and you could be kind of connected to your local area network. Everybody will be connected to for their area through their area local area networks without having to go to the site physically. Right. So what they do is they use a software controller to allow the communicate. So they'll use APIs to communicate to the SDN controller, and the SDN controller communicates with the OpenFlow to the data plane, to the actual routers and switches. So all the processing happens here. These devices don't have to process anything, right? Your local switches will be used to still move data around, but all the processing happens in the cloud, trying to figure out the best route to the destination. So the SD controllers using the OpenFlow protocol will calculate three tables: the flow, group table, and the media table. So please write that down. Um, so that will allow the flow packets. Just write down the three. You don't have to, if you want to write the definitions, that's fine. Uh, when it comes to the three core components of the application-centric infrastructures, they are the application network profile. Here's your Cisco APAC is that's the one, the software that allows you to communicate with the applications, and all the calculations happen here. And once the applications, the software controllers then sends the information to the specific switch, and then the switch will just interconnect all these different devices together. Right, so that's will be this is the big thing with Cisco now has. The Cisco Nexus 90,000 switches will provide the applications aware switching fabric that works with APAC. So you need these types of switches to allow the communications for the web, right? And then you have these big 9,000 series switches will send the information to the local devices, which is really the local switches. So everything happens really in the cloud up here. The three basic types, there is the device-based. You know, devices are programmable by applications by running the device itself on a server network. You have the controller-based, which is you have a centralized controller that have knowledge of all the devices on the network. And then you have the policy-based. You know, includes the policy layer operates. No programming is necessary once you connect. So this is a little bit easier. You just connect to that big APAC that connects to the 9000 series, and you'll be good to go. All right. So the Cisco APAC provides the following. I want you to write those six. What is it? Number? Yeah, six of them. They do discovery. They can use to they find out and populate the controller with all the devices that are connected that want to connect to the network. Inventory, all get information about who's the how many devices are in there and who's connected and what kind of data that they need to connect to traffic wise. The host inventory about the guy who's hosting them. Then we got the topology, the policy, and the analysis. And you can actually examine ACLs and all of that. So APAC can do all of that for you. So the local the local switches and routers, all you do is, since you're taking a lot of the work from them, and that's done in the cloud, data would move much, much faster locally. Right? So this way, nobody will compromise your router, your switches. They really just get information and move the data. All the security you can have. I mean, in the near future, they'll have the firewalls, the APSs, all of that. But then I don't know how that's going to work. If all the security happens in the cloud before your data is passed locally. So your big cloud is going to be the big thing. You're going to be able to set up firewalls, IPSs, you name it, and done in the cloud. So really that this is removes the VPNs, when you can create your own LAN. So you can have a huge company with thousands of users on one local area network, and the speed is very, very quick. But you still probably want to create VLANs. I mean, we're talking about something completely different than locally. So these big, huge cloud computing companies are growing. And if you take a look at Salesforce and see how fast they are growing, they're growing pretty fast, and everybody's jumping on it. Microsoft, the cloud services have also almost doubled since last quarter. So be aware of that. All right. And okay, so that ends the chapter. And I'll see you on the next chapter. So keep up the good work. And I'll see you then.